mode.
Okay, well, thanks everyone for showing up. We're going to get started here with the webinar on the network monitoring system for Powercode. So I'm going to run through some of the concepts of the system at a high level as to how it functions and what the features are, and then we'll get a little bit into some actual configuration to show the setup of some probes, setup of notifiers, and some of the things we can do with them. So the primary purpose of the monitoring system is to give you a way to monitor your network. What this allows you to do is get real-time statistics on how the network's performing. Look at the history over days, weeks, hours, or minutes, and then be notified when specific events occur. So the important piece with the monitoring to understand is that it's all actually performed by the BMU. So the billing server is the brain of the monitoring system, and it's what's going to take the results, store them, present them, but the actual monitoring is performed by the BMU. So the reason this is important is that you have to make sure all the gear in your network is able to be monitored by the BMU, that if you have any access lists or any controls on things like SNMP, that all of your BMU IPs are able to hit those pieces of equipment. The other thing that's important if you're using any kind of BMU redundancy is to know that the monitoring will fail over across those BMUs, but the master is always going to be the primary device to do the monitoring. So if you do have multiple redundant BMUs, it's important that all of them can monitor all the equipment. The monitoring that we can do today is just ICMP or SNMP. We do have some plans to add other types of probes in the future, but today it's pings and SNMP. So ICMP, most people refer to that as a ping. What we can do with ICMP probes is to measure latency and packet loss. So this is useful for monitoring situations that, you may not necessarily know what the root cause is or what it's going to be, but you know that you want to handle it if, say a backhaul is getting 20% packet loss or your edge router suddenly starts jumping up to 1,000 milliseconds of latency. SNMP is a protocol that's supported by, pretty much every networking device out there. And what this really allows you to do is retrieve a variety of information from a device. The types of info you can get are really dictated by the manufacturer. So give you a couple of examples on both sides of the scale. Cisco and Cambium are very good about presenting just about every piece of information you can possibly want to see in the gear. Ubiquity would be an example right now of someone who doesn't provide a whole lot through SNMP, but there's typically going to be at least a bare minimum of data you can get, like CPU usage, signal strength, memory usage, system uptime, those kinds of things. So the monitoring tools in Powercode are kind of split into two different pieces. We have the real-time monitoring tools that we've had in there for quite a while, and those are device and manufacturer specific. So we specifically build those on our side. They're not very configurable, but they're very easy. You just set a device to a supported device type, and you're going to get real-time statistics on all of that equipment. So for example, on a Cambium SM, you might see signal level, you might see jitter, the frequency that it's on, the color code it's using, all these different kinds of information, but they're all hard set and already in there. The historical probes that we have quite a few built in, but this is something that you can modify pretty extensively. So you can build your own probes, you can set your own thresholds for those probes, and we can define what's going to happen when one of those thresholds get violated. The other thing with the probes is that they're going to keep a history. The real-time stuff is purely real-time, right? What's happened 60 minutes ago or even 60 seconds ago is not necessarily going to be visible. The probes are all going to automate the historical gathering of data. So if you've used any kind of tools in the past to do this, like Cacti or SolarWinds or anything like that, one of the benefits of using these probes in Powercode over an external system like that is we're going to automate a lot of the creation of those graphs, because we can associate the probes with device types, and I'll show you that in a minute. So I've been talking a little bit about probes. Let's run through a quick definition of what the different things we have are. So a probe is just going to be a defined set of parameters for monitoring a device. So this is going to dictate the protocol we're going to use. Are we going to send a ping or are we going to use SNMP? And then what we're going to pull from the device and what our thresholds are going to be for notification, and then which types of devices we want to automatically associate these probes with. The notifier is, on the other side, the method that we're going to have to notify you when a threshold's violated. So we're going to define in there the method of notification, so it's going to be email, a text message, or a phone call, and then what threshold violation has to occur before that notifier goes out. So in our example we have here, we may have a probe that uses ICMP to measure the latency and packet loss to a device. And then we can set the device status to bad if the latency exceeds, whatever threshold you define. We got 500 milliseconds in here, but it could be 1,000 or 50. Notifier, we could set up to send a text message to your cell phone when the device is bad, but we can also specify, I want it to have been bad for 10 or 20 minutes before that goes out. So you have ways of controlling what the flow looks like of those notifications. So a device is just a piece of equipment in Powercode, and we don't really differentiate between network infrastructure and customer premise equipment when we talk about these devices. Even though they're added differently to Powercode, from a probe perspective, we treat them all in the same way. So, whether you deploy a backhaul on a customer account or you deploy a backhaul in your infrastructure, we're going to do the same monitoring on it. We can apply the same notification thresholds to it. And they're all going to be treated the same way. So as part of performing this monitoring, there's a couple of things that are important to understand on the equipment. So we have a status on the equipment, which is going to be one of 5 things. It can be unknown, it can be good, warning, bad, or down. So when we're monitoring equipment, the default status is good, right? If we can reach the device, then we assume everything's fine, and we're going to label it as good. The only way device is ever going to be in a warning or a bad status is because it's violated a threshold that's associated with one of the probes that are tied to that piece of equipment. For a device to go down, it has to fail its status check. And for a device to be unknown, it either means we've never monitored it, or all the BMUs that are available to monitor that piece of equipment are offline or unreachable in some way. So the first step in monitoring a piece of equipment is to run the status check. So the status checks that we have available in Powercode are an ICMP or an SNMP based check, or we can use both. And the way this works is if we have it set to an ICMP status check, we're going to ping the device 10 times, and as long as one of those pings come back, we're going to label the device as good and then move on to running all the probes. With the SNMP status check, we're going to perform a standard SNMP probe on the device, and as long as we get a result back, we'll label a device as good, and then we'll go through the rest of the probes. If you set both ICMP and SNMP, then it has to pass both of those checks. If it fails either one, it will be labeled as down. So the most important thing with a status check is if you don't have a status check on the device, then we won't probe it at all, because we'll never determine that it's good and move into the probing stage. So the vast majority of issues we have with people not being able to get probes working on their equipment is they haven't set a status check, so we're never trying it. So if we look at the logic of how this works, this is pretty much what I just described. We run the status check. If the device doesn't pass, we set it to down. If it does pass, we set it to good. If there's no probes on the device at that point, then we're done. The device is good in our eyes. I mean, there may be all kinds of issues with it, right? But we haven't defined any probes, so we're not looking at any other variables. If we do have probes, we're going to execute all of those probes, and then we're going to set the device status to whatever the worst status is from those probes. So if there's 10 probes on the device, 9 of them come back as good and 1 comes back as bad, we're going to set the whole device to bad. So here's an example from our actual monitoring system of some probes that we run on this equipment. So when you're looking at a piece of equipment, there's 2 tabs in here that are important when you're trying to figure out what's caused a piece of equipment to change its status. We're going to look at the Probes tab, and we're going to look at the Graphs tab. So under the Probes tab, we list out every probe that's defined in the system, and then when we last checked that probe and what the last status was that came back for it. So you can see in this particular case we got 4 probes that we run on this device. We have 3 SNMP probes, the first 3, and then we have an ICMP probe, which is the last one. And the first 3 probes are pulling from a Cambium SM, we're pulling jitter, we're pulling RSSI and signal, and then we're also pinging the device to check on it. So we have thresholds on these probes that we use to modify the status if they fail. For example, we have, if RSSI goes below 1,000, we'll set something into warning. And then we have techs that will look in-house at all the warning SMs and look at correlations. Do we have a lot of SMs in warning that are on the same access point or on the same tower? And then it lets us kind of get ahead of any problems that may be brewing. So when you look in the other tab that I mentioned, the Graphs tab, you're going to see all these same probes available there in the drop-down at the top. But instead of looking at what the last result is, we can look at the whole history. So we can spread this across any time frame we want. We got the preset times at the bottom, goes up to 30 days. But you can also set the start and end time manually. So I can look at this device across 24 hours, and you can see, our RSSI has been very consistent. The real value of this to us internally for our tech support people is that by looking at this history, they can really correlate what customers are saying. So I'll give you an example. We have a customer that calls in. Our help desk closes at 8 o'clock at night, but someone calls in the next day and says, well, from 10 to 1 a.m., my connection was really slow, or I had a lot of packet loss. And we can look at these graphs then and see, RSSI did drop at 10 o'clock down to 500, or our jitter went up to 10, from 10 to 1. And it allows us to start, number one, correlating what the customer is saying. Is this a problem that was on the network or with their premise equipment? And then look at those time frames and give us a direction to start moving into troubleshoot. So on the creating these probes, we've tried to make it pretty simple, but if you want to make any custom SNMP probes, you do have to understand SNMP a little bit, which we'll get into a little bit in this webinar. We do have a lot of templates built in for most of the common vendors in the WISP market. We have things in there for Cambium, Ubiquiti, Redline, Alvarian, Microtik, and a number of other vendors. So I'm actually going to jump into my Powercode installation now and take a look at what building a probe really looks like. So if you go to Network and then Device Probes, you'll see a list of all the probes. Right now all I have is this default ping probe. We can make as many probes as we want, so I'm going to make a couple in here and show you what that looks like. So if I click Add New Probe, first thing to look at is the type. So we have 3 different types that we can build. 2 are SNMP based and 1 is ICMP based. Difference between them is an SNMP probe allows us to probe any kind of SNMP data you want. An ICMP probe is going to let us send pings to the device. And then the interface throughput probe is going to allow us to graph the inbound and outbound throughput on an interface of any device. So we'll start with the SNMP, and then I'll show you how the other ones work. So the first thing is a name. I don't know what we're going to have in here. Let's say Cisco CPU usage. Now under the template drop-down, if I leave it on custom definition, I'm going to be able to build this probe from scratch. But if I pick one that's predefined, like maybe I want to look at the jitter on an SM, we're going to fill in as much of this as we can without you having to really do a whole lot. So as I cycle through these different types of probes, all of these fields are going to be filled in for you. Now you may want to modify these thresholds. We have some things built in that we think make sense. But you may want to change some of these to something that makes sense for your network. So let's pick one that's predefined in here. Let's say we want to do this Microtik router CPU usage. So the first thing we have is the SNMP OID. So this is going to be a collection of numbers separated by periods. And this is the format of an OID. And manufacturers will publish all the OIDs for their devices. You can generally get this information from them. It's also pretty easy through Google to search for Microtik router CPU usage OID, and you'll typically find that people have shared them on forums and that kind of thing. But we don't need to touch this because it's already been pre-populated. So if you move down to minimum and maximum, what this is for is that you can sometimes see with SNMP probes that you get results back that are that are incorrect, and whether this is because of a bug in the SNMP implementation for that device, or you get like a counter rollover or something. You can sometimes see numbers you don't expect, and it's going to skew your graphs. So by setting this minimum and a maximum, we're going to discard any values outside this range so that we know, something erroneous doesn't get added to our stat. So for example, we're looking at the CPU usage. We know it's going to be a percentage, and it's going to be between 0 and 100. We can't have -1 CPU usage, and we can't really have 150% CPU usage. So by setting this to 0 and 100, we know we're always going to show realistic values. Next thing we have is the data type. So you really have to look at the published specs from the manufacturer to know what this data type is going to be. But a lot of the time you can make a good guess. And, we have some information posted in the tooltip that explains this. But the difference between them is a counter is going to be something that constantly increases. So when you're measuring things like throughput on an interface, the way routers typically track that is they measure how much has been passed since they were powered up. So that would be an example of a counter. If it's passed, 1 byte through the interface, it's going to show 1. If we pass 1 more byte through the interface, now it's going to show 2. So then when you get that data, we'll pass that against the amount of time that's passed and figure out what the actual usage looks like. An example of a gauge would be something like CPU usage. This is going to be a static number, and it doesn't matter if it was 10 5 minutes ago and now it's 50. It wouldn't make sense to represent that as 60. So a gauge is going to be something that shows right now what is the value that's being sent back. Smart convert is something we added in that will help convert numbers that get very large into a smaller number by applying some kind of suffix to it. So, for example, if you're looking at throughput on an interface, typically it's going to be stored in bytes. Well, let's say you're transferring 800 megs a second. We really don't want to graph that in bytes because you're going to see this enormous value that's going to be very difficult to convert in your head. So by checking Smart Convert, it's going to look at what that value is and convert it down to whatever the smallest sane measurement is. So, if we're passing 800 megs, we'll show 800 megs. If it goes to like 1200 megs, then we'll show it as 1.2 gigs. And then if it drops down to 600K, we'll display it in K at that point. So this generally makes the most sense for things that are dealing with bits and bytes, but you can use it for other things as well. Unit of measurement, this is just something that gets shown on the side of the graph for reference. So, you just make this show something that's reasonable. I would say for CPU usage, it probably makes more sense for us to make this be a % sign or something like % CPU. So the status threshold, you see we have some things predefined in here. So really what this is giving you the ability to say, how do I want a device to be moved into these different statuses? So right now what we have set up on this template is this device is going to be good as long as the CPU is less than 50%. It's going to be in warning if it's greater than 49%, and it's going to be bad if it's greater than 80%. Now you may disagree and say, in my mind, it's only good if it's less than 25, and I'm going to say it's bad if it's greater, and I don't ever want it to go into warning. Well, you can do that, but generally we've got fairly sane things in there. If you're not sure, you can start with what we have and then modify them as time goes on. But once you've defined this probe, if you come back and modify this, it will modify all of the existing devices that have this probe. You don't have to go and do it device by device. Lastly, the modifiers we have. These are modifiers you can apply to the result to make it make more sense, in a human-readable way. So, for example, going back to interface usage, on most devices this is counted in bytes. Well, we normally talk about throughput in bits. We're assuming we're doing 10 megabit, right? Not how many bytes have gone through the interface. So we can set this convert bytes to bits, and then we'll be graphing that usage in bits. Divide by 10 can be useful because in SNMP nothing can be returned with a decimal point. So if you had, let's say, have something like a packet flux site monitor and you're using it to measure voltage, if the voltage was 12.5, most likely the device is going to return 125. So by putting this to divide by 10, you're going to see it. You don't have to do that conversion in your head. you're going to see it as 12.5. Lastly, the device types. Anything you select here, this probe is going to be automatically associated with all devices in your system that currently exist that are of that type, and it will also be associated with all future devices that are added of that type. So since we're doing MikroTik CPU usage, what I would probably do is at least come down here and check MikroTik router. I may also check the CPE and the access point. So the other probe types we have, the configuration is fairly similar. You know, the SNMP things obviously don't apply to ping, but we have the same thresholds. When we're doing ping, the only really configurable thing here is the packet size. Unless you have a reason to change this from 12 bytes, there's really no reason to. You know, this is the smallest packet size we can send, and it's going to be most efficient on the network. You may find there's some device out there that doesn't like 12-byte pings, and if so, you can increase it here, but most devices we've tested with are fine with that. One of the big differences with the ICMP probes is that we have two different ways to modify thresholds. We have latency and we have packet loss. And the worst one wins. So if I say, you know, good latency is less than 500, but I say warning packet loss is greater than 2%, if this thing comes back with 1 millisecond of latency but 3% packet loss, it's going to be moved into warning. You know, the warning's going to win out over what our good threshold is here. So you can set these to whatever makes sense, you know, for the particular device. Let's say I said this was my backhaul ping. You know, maybe in this case good latency is less than 50, and I'm going to say, you know, anything greater than 49 is bad. I want to know. And, you know, good packet loss is, maybe it's less than 1, right? And anything greater than 1 is going to be bad. And then again, pick my device type. So, you know, if I wanted to ping all my backhauls, maybe I'd come in here and pick the different backhauls that I use within my network. And again, it'll all get automatically associated. Interface throughput is the last one we have. 3 things you have to pick here is the counter type. It's going to be 32-bit or 64-bit. Only difference here is the speed of the interface. At 32-bit, the counters are going to wrap at about 110 megs a second, which means when you go above about 110, 120 megs, the graph's always going to look like you're doing 120 no matter what. This is just a 32-bit limitation. So if you change this to 64-bit, we can graph up into the gigabits. The device does have to support 64-bit counters. Most of them do. So I would go 64-bit by default. But if you find something that's not graphing, you can try switching it to 32-bit and see if that works. The interface is going to be the interface that you want to graph. So this has to be entered as a number, and this is how it's represented in the SNMP table. Well, you may not know what that is. So we can hit the scan device, and in here I can put in an IP address, I can put in what my SNMP community string is, and pick the SNMP version. And then if I hit scan device, Powercode will go and scan all the interfaces on that device, pull the names or the descriptions back from them, and then you can click on one of those interfaces to choose that to be the one you want to graph. Maximum value is kind of the same as the min and max on the SNMP graph. You know, occasionally when you're graphing these devices, maybe there's a counter wrap or there's some kind of issue, and you'll get some crazy result back that the interface did, you know, 50 gigs or something, which obviously doesn't make sense. So, for example, we know this is a gigabit interface. I know, well, there's no way a gigabit interface can do more than 1,000 megs, so I can set it to 1,000. Now, say we were graphing a backhaul, and you know, it has a gigabit interface, but wirelessly it can't do more than 200 megs. Maybe we'll set a maximum to something like 250, so we know if we get some value above that, it's going to be incorrect. Status thresholds on interface throughput can be used in a couple of interesting ways. So there's 2 ways of really looking at this. One is that, let's say you were graphing the port on your edge router, and you know, day in, day out, I never do less than 50 megs a second. You know, at peak maybe I do 500 megs, but even in the middle of the night, I'm always passing at least 50 megs. So you can come in here and say, well, if I'm doing less than 40, I want to know because maybe something's wrong, right? This is way outside my normal usage. Now, on the flip side, let's say we're graphing a backhaul, and this backhaul is only capable of doing 200 megs through the air. Well, if this backhaul starts getting up to 170, 160, 180 megs of usage, it's probably getting to be pretty close to time to upgrade. So in that case, maybe I say, bad throughput's more than 165. Now I'm going to get notified when this backhaul crosses 165, and if it stays there consistently, I might think, well, time to buy a new one. So again, same deal. Come down, pick the device types I want to associate with. So that's what adding a probe looks like. It's hopefully fairly simple, but we do have a lot of those SNMP probes built in here for different manufacturers. And if there is a device that you want to use that isn't listed here, then there's a couple of ways you can easily find things. You can either go to the manufacturer and ask them for the information. You can Google for it. There's a lot of them posted on our forum. We do have a sticky thread on our forum for people to post OIDs they're using that are useful. Well, the other thing you can do is let us know, if you find a device or you find some OIDs you think should be in Powercode. Just shoot us an email at support@powercode.com and we will throw them in the next update. So, back to the slides. So, the next thing we have is creating notifiers. So there aren't really any default notifiers in Powercode because we don't know who you want to notify and how you want to notify them. So we have a couple of ways we can do these notifications. We can send them by email, or we can send them through a third party that has a tool called PagerDuty. So the nice thing with PagerDuty is that it allows you to do some pretty complex notification rules and different notification methods, and we actually use this in-house for our ISP. Some of the features it has is on-call rotations. We can automatically escalate issues, and we can notify by email, SMS, or a phone call, which is the part I particularly like because at 3 o'clock in the morning, an email is probably not going to wake me up, but a phone call will. So I will run you quickly through what it looks like to create both of those notifiers by jumping back into Powercode. So under Network, we go to Notification Preferences. We have a couple of things we can do. We can make a notifier, and we can update this from address. So all this is the address that email notifications are going to come from. So, maybe you have something you want to set this to that make sure it doesn't get caught in a spam filter. So, maybe we would do network alerts at powercode.com. Notifiers are where we create the actual notification parameters, so we'll jump into doing that. So when you first make a notifier, we have the choice of email or PagerDuty. We'll start with an email notifier. So name is just a descriptive name, so I could say maybe this is our network operations on-call, and we're going to send these to oncall@powercode.com. Now we can pick what statuses we want to get notified on. So maybe you only want to know if something's good or bad, or good or down. You really don't care about it in warning. We have other employees that deal with things are in warning. So I'm the network engineer. I only really care if stuff's down. I got other people that deal with the other stuff, so we'll pick good and down. So the delay is how long you want to wait before you get a notifier. And a lot of people will come in here when they first set this up and put this at 0 because they say, well, I want to know every time that something happens. Well, depending on how aggressive your thresholds are in your equipment, this might result in you getting tons of emails because, in our last example we talked about, we had a throughput probe that we were going to have go out when a backhaul went above 165 megs. Well, do you really care if it goes above 165 megs for a split second, or do we care if it's above it for 30 minutes? So by setting a delay in here, we can say, make sure that this issue is actually ongoing and not some really transient thing. So you can set this to any number of minutes you want. Say we say we're going to wait for 10. Then we have two other parameters. We have repeat count and repeat interval. So the reason for this is, if we're sending out an email, say half the network's down, right? So we wait 10 minutes, we send out emails about half the network being down. Well, maybe you delete that email, right? It never goes out again, and you don't realize what's going on. So by putting repeat count in, we can say the number of times we want this this notification to repeat. So maybe I want to get 100 of these. The repeat interval is the interval between these repetitions being sent. So we have a delay of 10 minutes. So at this point, something would have to be down for at least 10 minutes. And we got a repeat count of 100. And I'm going to say my repeat interval is 5. So what this is going to mean is after 10 minutes, send me a notification. And then as long as one of these selected statuses persists, continue to send me these notifications 5 minutes apart until 100 notifications have been sent. Same as the probes, we can associate this notifier with all different kinds of devices. So because this is on knock-on call, I probably don't want this on SMs. I don't really want to know every time a customer's SM goes down because they unplugged it or they have a power outage. But I do care about my backhauls. I care about CMMs, my access points, my switches and routers. Or maybe I have a notifier for almost every different device type because I have different people to get notified on them. Maybe I'm just the wireless guy. I don't care about switches and routers. I just need to know if the backhauls or the APs go down. So by selecting these, same as the probes, these notifiers would apply to all existing devices of these types and all future devices of these types. So one of the big benefits of having this method of assigning these device types is that when you add a new device, it's going to get all the probes and notifiers you've defined automatically. You're not having to come in and add these every single time. And this is part of the challenge of a lot of using these external systems, is you've got to remember, I've deployed a backhaul. I've got to go put it in Powercode. I have to go put it in Cacti, and now I'm going to log into Cacti, and I'm going to associate all these probes I want with it. The more interaction you can take out of the equation, the less problems you're going to have with human error. So let me show you an overview of a piece of equipment here quickly so I can show you a couple of the other features we have. So this is in my development system, so here's my PowerBook that I use for testing a lot, and you can see I have a status check of ICMP here, and currently it's down, so I'm checking this by pinging it, and it's down, and it's been down for 22 days, so I haven't done anything with my laptop in Powercode for 22 days. Now, if I had a notifier on here, which I don't currently, but if I did, I would have been getting paged about this. Well, one of the things we have is this suppress paging option. So what you can do with the suppress paging is if you're the guy that's on call and you're dealing with something and you have 100 repetitions of this alert going out, once you start working on it, you probably don't really care about getting these alerts anymore. So I can come in here and hit suppress paging, and I have three options. I have temporary, and what temporary will do is suppress paging until the device status becomes good again, and then we'll lift the suppression. We have timed, which can be minutes or hours, where I can say, I want this thing to stop paging for 6 hours, but I don't know if I'm going to remember to lift the suppression, so I want it to automatically be lifted in 6 hours. Or we can do permanent. Permanent means it's going to suppress forever until someone comes and lifts this. So if I hit confirm in here, now you can see paging suppressed permanent. So now paging will immediately stop for this device until I come and lift it. It's never going to lift. Now, that's useful in some situations because maybe this is a backhaul you're taking down. It's going to be down for 3 months, but you don't want to delete it out of Powercode because you've got history on your graphs and it's already all set up in here, but you don't want it paging forever. So rather than going deleting all the notifiers or deleting all the probes, we can just suppress the paging. Now, one of the things that can happen when you do that is, what happens when you forget, right? Someone's permanently suppressed 1,000 devices and you forget. Well, under network, if you go to network dashboard, we have some reports down at the bottom. So this, it's just showing us the status of the whole network. We have a couple of things down at the bottom. We have a report that gives us a list of all the suppressed devices. And we can also actually come in here and turn off paging for everything. So let's say you have a huge network outage, right? You don't want to go suppress everything individually. You can come in here and say suppress everything. But if I click on the suppress devices link, it's going to tell me, here's my PowerBook I just suppressed. So it makes sense to kind of review this list fairly regularly if you use the paging suppression so that you remember the things that you have suppressed and they don't get suppressed permanently. Generally, the temporary makes the most sense. If it becomes good, it's going to be lifted automatically, and then you don't have to worry about it. Okay, so once you have all your equipment in there, you're probing it, you have these notifiers set up, everything's working great. You want a way to look at all this equipment at a high level. You want to see what's really going on with the network. So we have a couple of ways of doing this. We have the network map, which is going to be a geographical representation of the network. Then we have a network dashboard that's going to be a representation by type and by category. So I'll show you a couple of examples. Here's a snapshot of the map from our network. So you can see we have a couple of different things set up here. We have some towers on the map. We have some backhauls that are linking the towers together. And these are all colorized by the statuses. So devices are going to be, or locations are going to be green if they're good. They're going to be yellow if they're in warning, and then they're going to be red if they're down or bad. So just the same as the way the probes affect devices, devices affect locations by the worst status. So if I have a location that has 1 down device and 100 up devices, that location is still going to be red because we're going to look at the worst device when making that determination. These backhaul links are treated the same way. If any one end of the backhaul is either warning or bad or down, then that whole backhaul line is going to show as up or down. Now, the way these towers are linked up is that we use the parent-child system. So when you put devices on towers, if you set a device on another tower or another network site to be the parent or the child of a device on another site, we'll automatically draw a line between those towers to represent they're connected. So this is typically done with things like wireless backhauls, but I mean these lines could easily be fiber, right? Maybe we have a router at each site that we use the parent-child system to link to each other, or maybe they're linked by some other method. The other thing the parent-child system is going to do is control how notifications go out. So one of the things we look at when we send notifications is, are all my parents up? So if you have a device that has one or more parents and it goes down, if all of the parents are also down, we're not going to send a notifier for that child device. We'll only send it for the parents. So the value of doing this is if you have, say we have a router at a site that everything's plugged into. Well, if you make all the devices of that site children of that router, if that router goes offline, you'll get one page for the router. You're not going to get 50 pages for the router, the backhauls, the CMM, the access points, UPS, everything else you might have at that location. So the other overview we have is the network dashboard, which is similar to the one I just showed you in my dev system. So at the top we get a real high-level overview of how much equipment we have that's impacted in the network today. So see, I've got some test data in here that's showing 249 pieces of good infrastructure, 131 down, and you can click on these big squares at the top that will give you a report of all the devices that make up that count. Then down below that we have all the devices broken up by category and then by device type that again will show you how many devices are in each status, and then you can click on those statuses to get a listing of all those devices. So when you look at the monitoring system in Powercode, when you're looking at a small network, you can pretty much do whatever you want. The BMU scale to be able to do a pretty significant amount of probes in a pretty short amount of time, but there comes a point where, if you have thousands or tens of thousands of devices that you're monitoring, that, you may want to think about the scalability of it a little bit. So some of the things we can do to scale is not using ICMP for everything. If you have good SNMP probes built, it probably don't really need as much ICMP data. Generally things like latency increasing on the network or packet loss increasing on a device are going to be, a symptom of a larger problem. So if we're monitoring, for example, a modulation of our backhauls and we're monitoring the CPU usage of our routers, maybe we don't really need packet loss and latency stats for those devices because we already know if the modulation drops down really low that, we're going to have problems there, that potentially latency is going to start increasing. The other thing that's beneficial with SNMP is if you have 10 SNMP probes on the device, we can probe all 10 of those things at the same time. But if we're pinging the device and we're sending 10 pings, we have to send those sequentially. There's no value in sending all of them at exactly the same time, because if we do that, they're all either going to come back or they're all going to drop. The other thing you can do is use a bigger BMU. So the BMUs that we have, they have a hard set limit on how many probes they'll do simultaneously. The NX216 will do 25 at a time, but our Max 104G will do 50. Last piece is not monitoring devices excessively. So it's tempting to just probe as much data as you can because who knows when you might need it. But if you're pulling tons of stuff from tons of devices, then at some point it's going to start taking a long time to get all that data back. So look at the things that are helpful. CPU usage on a router is helpful. Temperature on the router might be helpful. The amount of memory that's available on the router might be helpful. But there's a lot of stats you're going to be able to get from it that aren't really going to do you much good for troubleshooting. So scaling notifications, you kind of have the same thing. I mentioned the parent-child piece. So if you have a lot of devices, using the parent-child system to link them is going to squash a lot of needless notifications. Because like I said, if all the parents are down, we're not going to notify the children. The other thing you can do is use PagerDuty. So, when I found PagerDuty, we began using it right away, and I'd really recommend using it for networks of any kind of significant size, because it's going to make it a lot easier for you to control the alerts. It's going to make it a lot easier for you to set up things like escalation rules. I'll give you a real-world example. If I get 100 devices down that are going to send out 100 alerts, if I send them out by email, I'm going to get 100 emails. If I send them out through PagerDuty, PagerDuty is going to send me a single text or call me or send me an email or whatever I want, and it's going to tell me there's 100 things down, and I can hit a button on my phone to acknowledge all of those alerts and stop them paging and then go investigate what's going on. So, again, I'd really recommend it, and it's not terribly expensive. So a couple of other tips we have. If you're going to use ICMP for your status check, you may as well add an ICMP probe, because we'll use the data that comes back from the status check to populate the probe data. So if you're using both an ICMP status check and an ICMP probe, we're only going to send 10 pings one time and use that data for both things. Also, the other thing I mentioned was finding these OIDs, deciphering the MIBs that the manufacturer would give you for all these OIDs can be difficult, but I've found 9 times out of 10 if you Google what's the SNMP OID for XYZ, the first couple of results are often going to provide it for you. There's also, for some manufacturers, they do provide easy online tools to find OIDs that you're looking for. The Cambium one is particularly good, and I have the link in the presentation here. Cisco one is also very good, and there's probably some others out there. I haven't looked for every manufacturer, but the bigger ones do tend to build these online tools to help you find OIDs. So troubleshooting these probes, again, common support requests we get are people say, I built this probe and it's not graphing, or I'm not getting data back. So there's, a couple of reasons for that. The most common one is the device is not returning the data, and this is going to be either the SNMP community string you're using, which is essentially a password for SNMP to allow you to get data from it, is wrong, or using the wrong SNMP version, or you have the wrong OID. So the easiest way to validate if this is the case is to test, outside of Powercode. You have a couple of ways of doing this. You can test from Windows. There's a tool, SNMP probe, you can use that's going to allow you to do some test probes on a device and see if you get data back. But you can also do it from the command line on your billing server. So if you want to do it from the command line, this is how you would do it. And we will be putting this on YouTube afterwards if you're worried about this data going off the screen too quickly. But you would SSH in and run SNMP get and then a -v for the version. The version's either going to be 1 or 2C, and if you're trying to figure out which version your device supports, this is an easy way of trying them both and seeing which one works. The letter Y we have in here is the community string, so you do a -C and then the community string, and then the IP address that you want to query, and then Z would be the OID. The other thing you can do instead of SNMP get is to type SNMP walk, and what this will do is start running through every single OID the device supports and outputting the result from that OID. So if you're just trying to figure out what OIDs are available on the device and what kind of data you can get back, running an SNMP walk is a good way of doing that. Couple of caveats with SNMP. We only handle numeric responses right now, so you will see SNMP results that get returned as a string. So a numeric response is going to be a number, so 1, 2, or 3. A string response is going to be something like the word up or the word good. Frequently, if with the manufacturers that have good SNMP implementations, if they have an OID that gives back a string, most of the time they're also going to have an OID that gives back a number. Some manufacturers don't, but the vast majority of them will. So some things we've been talking about, the OIDs and the MIBs. So the OID is an object identifier. So this is just a key that returns specific information about a device. And the MIB stands for Management Information Base. Essentially all this is just a document that lists all the OIDs available for a device. So if you were to email a vendor and say, I need a MIB for my Trango backhaul, or I need a MIB for my Canopy SM, they're going to know what you're talking about. So a couple of final things I'll mention before we finish this up. You can get somewhat creative with some of these things so that you're you're not just being reactive, you're being proactive. So in the beginning when we started network monitoring, we were pretty reactive, right? We'd settle up probes so that if something went offline, we'd all jump up from what we were doing and we'd run out and fix it. Well, sometimes that's the best you can do. If a backhaul gets hit by lightning, then, you can't really do anything until it gets hit by lightning. But there's some things that creep in over time, and so we tried to build some probes to help us find this. So a couple of examples I have from inside our network is we graph and we track how many satellites our Canopy CMMs are tracking. And the reason we do this is we'd found in the past if we had a CMM that had, say, 10 visible satellites, but it was only tracking 4, that we had some kind of a problem out there. Maybe the antenna needed to be replaced, maybe it was positioned poorly, maybe the CMM had a problem. So we have some thresholds in here where if our CMMs are tracking, I think, less than 5, maybe less than 4 satellites, we'll throw them in a warning. We'll just go take a look at it and see if, if we have a problem there. So if you guys have any questions on the monitoring system, a good place to post them is actually on the forum. We have a lot of other customers that are using the monitoring system. We've had a lot of good ideas about ways to utilize it. You can also refer to our wiki. We have a lot of information on there about configuring it. Or, of course, you can shoot us an email or give us a call at either support@powercode.com or by phone at 920-351-1010. So thanks for coming. I hope you found the webinar useful, and we will hopefully see you guys on the next one.